current electricity topic. This is section 8.1, charge. Now it says charge again because you probably got most of what you're going to see in this topic when we did the previous topic, electrostatics. But since the concept of charge is so critical, so basic to understanding how current electricity works, just in case you didn't quite get charge when we did electrostatics, or you don't quite understand exactly what an elementary charge is, or how to figure out the total charge when you know how many electrons you have, we're going to take a look at charge one more time before we delve completely into the current electricity topic. Now again, what I will be talking about in this section is if you have a certain number of electrons, like let's say you have 50 electrons, right, number of electrons. How do you convert the number of electrons that you have to the charge on those electrons? In other words, if you have n electrons, right, how do you convert that number of electrons to a charge, right, a total charge, or just how much charge do you have? You can say the total charge or you can say the charge, it doesn't really matter. Right? And if you have a certain amount of charge, how do you convert that to, well, if I have a certain amount of charge, how many electrons is that? And the reason that this is going to be important is because knowing how to do that, right, might come up, often does come up, when you're asked in the current electricity topic to calculate the current, the voltage or potential difference, right, or the electrical energy or work, W, electrical energy or work. Right? The concept of Q, charge, is going to come up in all of these circumstances because the current is going to be defined as the charge per unit time. So there's that charge, all right? All right, the voltage is going to be defined as the work per charge, all right? And the work, or the electrical energy, based upon this equation, just rearrange it, all right, is going to be defined by the amount of charge and the voltage, right, multiplied together. All right, so you see charge, charge, charge. Charge, the concept of charge, is going to come up in the current electricity topic as moving forward from where it came up in the electrostatics topic. So we're going to start by talking about charge again. If you feel that you're comfortable converting electrons to charge and charge to electrons, then you might want to skip this section, right? If you feel that you'd like to get a little refresher before you move into the current electricity topic, then this section is for you. Here we go. Perhaps you remember from the electrostatics topic that the symbol for charge, right, here's charge, right, and the symbol for charge is a lowercase q. And the unit for charge is an uppercase C, and that stands for Coulomb. Now, perhaps you also recall that at one time, the smallest charge that we thought was possible was called one elementary charge. One elementary charge. And that would be, if we're talking about a proton, positive 1.6 times 10 to the negative 19 coulombs. That's the charge on a proton. Or, if we're talking about an electron, negative 1.6 times 10 to the negative 19 coulombs, and that's the charge on an electron. Notice that the exponent is 10 to the negative 19 for both the proton and the electron. and 1.6 for both the proton and the electron. That's telling you that the magnitude of the charge, in other words, forget about the plus and the minus, all right? The magnitude of the charge on the proton and the electron is the same, but the charge, all right, the sign of the charge is opposite. So a proton is positive 1.6 and an electron is negative 1.6. Now, we now know that quarks have smaller increments of charge, 1/3 of an elementary charge or 2/3 of an elementary charge, but that doesn't really come up in this topic. You're going to see that in the modern physics topic. And keep in mind also that quarks don't like to be alone by themselves, whereas electrons and protons can be stable by themselves. All right, so our concept of the elementary charge basically still holds, even though we have discovered quarks to be smaller. All right, protons are made up out of quarks. All right, I digress. Now, what I'm going to focus on in this topic, of course, in this section, is the electron. Because we're talking about electricity, it's electrons that are moving, it's electrons that we're talking about. So what we're going to be focusing on is the fact that every electron has a charge of negative 1.6 times 10 to the negative 19 coulombs. So here's an electron, all right, here he is right here, and he has a charge of negative 1.6 times 10 to the negative 19 coulombs. Now, many people do not like this number. It's an odd number, all right? Once you get comfortable with it, it's fine. But in the beginning, sometimes it's a little difficult to wrap your head around this number and do calculations with this number. I'm going to do a weird little analogy that might be helpful to some of you. If you don't find this analogy helpful, then just forget about it. If you already get the concept that I'm looking at, then forget about this little analogy. But if you have trouble with deciding, well, if I have 50 electrons, how much charge is that? Try this little analogy, all right, and see if it helps you to straighten that out. What if on some weird universe, all right, in some other universe, not ours, what if the charge on an electron, instead of negative 1.6 times 10 to the negative 19 coulombs, what if the charge on an electron in this weird universe was negative 3 coulombs instead? All right, now this is not by any means something that happens in this universe, but I want to use a simple number that we all know and love, the number 3, right, and try to get an analogy going for how to figure out, how to derive a little equation to figure out, well, if I have a certain number of electrons, well, how much charge do I have? All right, so bear with me, okay? So if each electron is negative 3, what if you had 5 electrons? 1, 2, 3, 4, 5. Each electron would be negative 3 coulombs. So the total charge that you would have would be, take the number of electrons, multiply by the elementary charge in our weird universe, which is negative 3, all right? And by the way, that's negative 3 coulombs per each electron, right? Negative 3 coulombs per electron. Each electron has negative 3 coulombs, all right? Take the number of electrons, multiply by that negative 3. Well, how much total charge do you have if you have 5 electrons in this crazy universe where the elementary charge is negative 3? You're like, well, it's negative 15. I get that. My total charge, right, Q total, or just Q, how much charge, all right? So let's take this little equation that we've kind of generated, flip it around, all right? The total charge that we have is equal to the number of electrons times the elementary charge in our crazy little universe. So, what's the total charge? Well, we've got 5 electrons, and in our weird little universe, let me just push these guys over here. All right, in our weird little universe, all right, the elementary charge is negative 3 coulombs per electron. And what ends up happening, okay, is electrons cancel with electrons, and we get that the total charge, all right, is negative 15 coulombs. So you see where we're getting this equation from. We made up our own little equation that says, well, if you know how many electrons you have, and you know the charge on each electron, you can calculate the total charge by multiplying. That's simple, right? Okay? So now, what if you knew the total charge and you wanted to know how many electrons that would be? All right, what if I said to you, okay, the total charge is 24, negative 24 coulombs. Now, we're trying to find out how many electrons, n. So I'm going to solve for n by dividing both sides by e. All right? So we get that n, the number of electrons, is going to be the total charge divided by the elementary charge in our weird little universe, where the charge on an electron is negative 3. So, the question says, well, if you've got a total charge of negative 24 coulombs, how many electrons do you have? Well, the number of electrons is equal to the total charge divided by the elementary charge. The total charge, we said, was negative 24 coulombs. And the elementary charge in our weird little universe, we have no idea where this universe is. It's not our universe. But each electron is negative 3. That's negative 3 coulombs per each electron. And I want to know, okay, well then, how many electrons is that? Well, you divide. The negatives cancel. 24 divided by 3 is 8, right? 8. Now, we're gonna invert, all right? Electron per coulomb, and multiply top and bottom. Electron per coulomb. This is all canceling, okay? Coulombs cancel. Electrons is what's left. 8 electrons. You don't really need all the units. If you understand the units, great. If not, just focus on, well, it's 24. Each electron is 3. That means I got 8 electrons. Okay? Are you starting to see how you can convert from number of electrons to total charge, and from total charge back to number of electrons? All right, so now hop on the Starship Enterprise and come back to our universe, okay? Where an electron, the elementary charge, is not negative 3. It's this weird little number, okay? This tiny little number, all right? How much charge? Yeah, let me just pull our 8 electrons here, just to finish that thought. Here's 8 electrons, right? And in our previous problem, each electron is negative 3. We said that. So the total charge that we were talking about was negative 3, negative 6, negative 9, negative 12, negative 15, negative 18, negative 21, negative 24. All right, that's where that 24 charge came from. And each electron was negative 3, so there were 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so putting that aside, all right, and coming, like I said, hop on the Starship Enterprise, come back to this universe, and let's look at reality. And apply the concept of using this little equation, all right, the total charge, you can say charge total, or just charge, how much charge, all right, is going to be equal to the number of electrons we have times the elementary charge, which in our universe, on our Earth, all right, and on Jupiter, and in Alpha Centauri, and everything in our universe, all right, the elementary charge is negative 1.6 times 10 to the negative 19 coulombs. All right, it's not negative 3, it's that number. So, let's say that we had 1 electron. We'll put him over there. 1 electron. All right? 1 electron, and I want to know how much is the total charge. 1 electron, each electron is negative 1.6 times 10 to the negative 19 coulombs. Okay? So that means the total charge is, and I'm going to erase that a little bit there. All right, the total charge is negative 1.6 times 10 to the negative 19 coulombs. What if I had 2 electrons? Well, 2 times negative 1.6 times 10 to the negative 19 coulombs. The total charge that those 2 coulombs have would be 2 times that. That would be negative 3.2 times 10 to the negative 19 coulombs. The total charge, or whatever, just the charge. How much charge do I have? All right? If I had 3 electrons, and each one is negative 1.6 times 10 to the negative 19 coulombs, then the total charge that I have is negative 4.8 times 10 to the negative 19 coulombs. And you can go on and on and on and on and on. Customarily, I try to get my students to memorize up to about 6 electrons. So let's see, 4 times that number. All right, the charge on 4 electrons, if each one is 1.6, then 4 times that would be negative 6.4 times 10 to the negative 19 coulombs. All right, 5 electrons, I'm going to write a little smaller because I'm running out of space here. 5 electrons times that much each, all right, would be negative 8 times 10 to the negative 19 coulombs. And I think I have just enough room here for 6 electrons times negative 6 times 10 to the negative 19 coulombs each. All right, there's 5, there's 6. 6 electrons, what's the total charge that they have? Negative 9.6 times 10 to the negative 19 coulombs. All right? So, we get that we've got this little equation. This is, the N would be how many electrons do you have? The E is the elementary charge on 1 electron. And in our universe, it's not going to change. It's negative 1.6 times 10 to the negative 19 coulombs. So if you multiply the number of electrons times the elementary charge, all right, and I'll show you one thing again with the units, you're going to get your total charge. How much charge does that number of electrons have? All right, so now you should copy down this equation. You're probably not going to see this equation anyplace else. This equation is more like physics common sense. But if it helps you to have a little equation, then that's a good thing. All right? So there's your little equation. Like I said, you're not going to see that equation. You're probably not going to see it on the internet. You're not going to see it in a textbook. You're not going to see it on any reference tables. All right? It's more like physics common sense. All right? So there's your charge or your total charge. Okay, so total charge, or just, how much charge is equal to the number of electrons, all right, times 1 elementary charge. And we know that 1 elementary charge for electrons, forget the protons, we're not talking about protons today. All right, the 1 elementary charge for electrons is negative 1.6 times 10 to the negative 19. All right, now, just a little word about units. All right, N is the number of electrons, so let's just say it's 2 electrons. All right, and the elementary charge is really negative 1.6 times 10 to the negative 19 coulombs per electron, or coulombs per proton, but we're not talking about protons today. All right, so what happens is when you multiply these together, all right, 2 electrons, negative 1.6 times 10 to the negative 19 coulombs per electron, you get coulombs. All right, so the total charge on 2 electrons is negative 3.2 times 10 to the negative 19 coulombs, right? The electrons cancel. You don't have to put the word electrons in there. You don't have to put it there. You don't have to put it there. All right? You could just go like that. 2 electrons, all right? 2 electrons times that many coulombs, that's the total charge on 2 electrons. You don't need the total there either. How much charge do I have? That much. Okay? Again, if you know how much charge you have, and you want to know, well, how many electrons is that? Okay? Then let's just rearrange this equation to solve for n instead of q. All right? And remember, if there's anything you need to copy down, if there are any notes you want, all right, just pause the video or start it over. Okay, go back a little bit. All right, so remember, if you want to know how many electrons you have, that's going to be the total charge divided by elementary charge. Okay, so if you have, let's say, a total charge of negative 4.8 times 10 to the negative 19 coulombs, all right, and you want to know, well, how many electrons is that? All right, you're going to divide by one elementary charge. You don't need the parentheses, that's not necessary. All right, you're going to divide by 1.6 times 10 to the negative 19 coulombs, all right, and you're going to say, oh, that's, if you plug that into your calculator, that divided by that, all right, you're going to get, well, that's 4 electrons. N equals 4 electrons. All right, how do you end up with electrons? This much charge divided by this much charge per electron. All right, remember you flip whatever, the coulombs cancel, and you get, you get 4 electrons. Okay. Keep in mind also that the 10 to the negative 19s are canceling, right? It's really 4.8 divided by 1.6 is what's left, and you're getting 4 electrons. All right, so that's a little introduction to a little equation, all right, a little analogy, right? Here's my little electrons, okay? And they each have 1.6 times 10 to the negative 19 coulombs. So this was the little analogy, all right, and a little equation to help you to convert back and forth from number of electrons to charge. Okay, so at this point we're going to move on to more things that relate to these concepts. All right, so now we know how much charge one electron has. It's a tiny, tiny little number. One electron has negative 1.6 times 10 to the negative 19 of this unit coulombs. Let's take a look at that number in decimal form. All right, here's 1.6, and we're going to jump 19 places to the left. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we've got 1, 2, 3, here's my decimal over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 zeros. All right, so the number, what this number really is 0.0000, that's 4, we need 18 zeros, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, all right, 1, 6 coulombs. Wow. Okay, that is a tiny, tiny, tiny number. So one electron has a tiny, tiny number of coulombs. So that means that compared to the amount of coulombs that one electron has, 1 coulomb is huge. This number is huge compared to this number. Okay? So, now we want to figure out, well, how many electrons are there? If this is how much each electron has, how many electrons are there in 1 coulomb? All right, let's write that down as a question. Calculate calculate how many electrons there are in 1 Coulomb of charge. And remember, this is a huge number compared to the amount of coulombs that one electron actually has. So would you expect that it's going to be a lot of electrons or just a few? All right, let's find out. Now we can use that equation that we made up, all right, that common sense equation. All right, the number of electrons is equal to the charge divided by 1 elementary charge. I've got a certain amount of charge. I've got 1 Coulomb of charge. I want to know how many electrons would that be. So I'm going to divide by the number of coulombs per electron, the elementary charge. All right, so here we go. All right, let's move that over here. All right, the number of electrons is going to be equal to the charge, or the total charge, whatever, okay? You can call it total charge or just call it charge, divided by the elementary charge. So here we go. The total charge is 1 Coulomb. The amount of charge per electron is negative 1.6. Now, I'm sorry, if this is a Coulomb of electrons, then that's negative also, okay? Negative 1.6 times 10 to the negative 19 coulombs per electron. Now remember, you can just put coulombs. Just cancel the coulombs and not worry about the word electron there. All right? You don't have to have the word electron there. All right? You can just say 1.6 times 10 to the negative 19 coulombs. Okay? The per electron part is understood. We know we're talking about electrons. All right. So you pick up your calculator, all right, and you put in, all right, 1, right? That's 1, divided by 1.6, all right, times 10 to the negative 19. However you put exponents into your calculator, okay? And I get, wow, that is a big number. 6.25 times 10 to the 18th electrons. All right, the number of electrons is huge. That's a big number. All right, let's see exactly how big that number is. All right, how many electrons is that? We change it into a decimal, okay? Much as this number was really, really small with lots of zeros, this number is going to be really, really big with lots of zeros. All right, 6.25 times 10 to the 18th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 zeros. All right, so let's draw that with 16 zeros. Let's see how big this number really is. All right, 6, 2, 5. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's a comma, 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 there's a comma. All right? So this is thousand, this is million, this is billion, this is trillion, this is quadrillion, all right? And this is quintillion. So it's 6.25 quintillion, right? Electrons. Wow. That's a lot of electrons. All right? 6.25 quintillion electrons. Thousand, million, billion, trillion, quadrillion, quintillion. All right? That's how many electrons there are in a Coulomb. All right, in 1 Coulomb. Okay? So, if I wanted if I wanted this little black dot here to represent, instead of representing just one electron, I want this to represent 1 Coulomb of electrons, all right? That would be this many electrons. That's a lot of electrons. Remember we said that the number 1 Coulomb is huge compared to the charge on 1 electron. This number, the elementary charge, is so tiny that to have 1 Coulomb, you need this many electrons all chipping in their elementary charge. All right, so now when I start talking in other sections about current, about voltage, a lot of times I'm going to have this one little dot. Instead of the one little dot representing 1 electron, I'm going to have the dot represent a Coulomb of electrons. In other words, that many electrons. So if I had 3 Coulombs, all right, there's another Coulomb, and there's another Coulomb. That's a lot of electrons. It's 3 times that many, all right? If this is 1 Coulomb, and this is 1 Coulomb, and this is 1 Coulomb, all right? So now on the front of your reference tables, it tells you flat out, it tells you that 1 Coulomb, all right, on your reference tables, it says, look on the front, okay, that 1 Coulomb equals 6.25 times 10 to the 18th. I think it says elementary charges, so that could be electrons or protons, but let's just say electrons, okay? So that number is there. You don't have to calculate that number. You know that that is the number of electrons in 1 Coulomb of electrons. All right, so that's our second little concept here in this section. All right? Moving on. Now, what we've been leading up to with the beginning of this section is to use equations that have charge as part of the equation. There are 2 equations, and actually 2 versions of one of those equations that are going to be really, really important in this topic. First of all, the equation for current. Now, you're going to do current, capital I, in the next section, all right, in 7.2 or maybe 7.3. All right, but the equation for current is charge per unit time. All right, and the reason we're doing this little mini section right here, this section 8.1, is because if they tell you how many electrons you have in a certain amount of time going through a wire, and then they ask you to calculate the current, you're going to have to take the number of electrons that they gave you and convert that to the charge that those electrons have. So if it's 5 electrons, all right, if you've got a total of 5 electrons, that's going to be 8 times 10 to the negative 19 coulombs, right, etc., etc., etc. Now, we'll talk about that again in just a minute. Now, if they give you the current and the time, and they ask you, well, how many electrons is that? You're going to have to get the charge first with this equation, and then convert that charge to number of electrons. And again, the equation that helps you go back and forth between from number of electrons to charge, charge to number of electrons, is that little common sense equation, all right? Q is equal to N times E, or N is equal to Q over E. All right? And another way you could think of this, to go from number of electrons to charge, you're going to multiply by 1.6. So to go this way, you're going to multiply by negative 1.6 times 10 to the negative 19 coulombs. To go from charge to electrons, from charge to number of electrons, you're going to divide by negative 1.6 times 10 to the negative 19. So to go back this way, you're going to divide by negative 1.6 times 10 to the negative 19 coulombs. All right, now, another equation that uses charge in the current electricity topic. This is the definition for current. Another one that uses charge is the definition for voltage. And again, we'll be going in a lot more detail in the voltage section. All right, look up in the on the table of contents, so to speak, for this topic for current electricity. But I believe it's going to be section 7.3 or 7.4. Okay? So voltage is defined as the amount of work per unit charge. There's the charge. If they give you the number of electrons, instead of giving you the charge straight up, and they're asking you for the potential difference or the voltage, if they give you the number of electrons, you're going to take those electrons and convert them to charge. All right, again, take the number of electrons, multiply by the elementary charge to get your charge. So again, that's times negative 1.6 times 10 to the negative 19 coulombs, going that way. If they give you the voltage and the amount of work, that's joules, and they ask you for, well, how many electrons is that? Then you're going to take the charge that you get, the coulombs that you get, and convert that to how many electrons by dividing by negative 1.6 times 10 to the negative 19 coulombs. All right? So again, the reason we're doing this whole topic is because charge is going to come up in a lot of equations in the current electricity topic. And if they give you the number of electrons instead of the charge, it's very, very simple to convert the number of electrons that you have to the charge that you have. If they ask you, well, how many electrons, and they give you, for example, the voltage and the work, or the electrical energy, you can calculate the charge, and then it's very, very easy, once you know how much charge you have, to figure out, well, how many electrons is that? All right? So, again, this topic overlaps with the previous topic a little bit. This section of this topic overlaps with electrostatics. You probably realized this when you were doing electrostatics. But just in case it was a little fuzzy, I hope that starting the current electricity topic with a little review, right, and some cute little analogies and a cute little equation that, as far as I know, doesn't exist in any book anywhere, that this will help you to have to be able to go right into current electricity without any confusion and understanding how much charge each electron has, and how to figure out, if you have a certain number of electrons, what the total charge is. Aren't these little electrons adorable? If you have a certain number of electrons, what's the total charge that those electrons have? I will see you in the next section.